Hi guys, today I will be presenting our integrated design project called Pyrecam with my team members Uge, Delphine, Saad, and Marcus. So our product, Pyrecam, is a camera-based application, essentially a software as a service that takes a smarter approach towards efficient monitoring, detection, and alerting of illegal cigarette smoking in non-smoking zones, which include public areas and industrial hazardous areas. So our features and benefits include machine learning incorporation that accurately identifies smoking offenses in non-smoking zones. Furthermore, the inference and video streaming is performed on the device itself for privacy reasons and for bandwidth efficiency. So only frames containing detected smoking offenses are sent to the server for processing. Another benefit of our product is that it is fast and reliable. Real-time notification is immediately sent to relevant authorities to take action once smoking offense is detected. This is done through a web interface and through SMS containing date, containing the location, and containing the picture of the smoking offense. So our problem statement is that to enforce smoking regulations, an authorized officer has to be in a specific location to monitor that area 24/7. This is not efficient and is realistically unlikely due to wide area coverage in some places and periods of rest when the officer is not working. During these scenarios, the following issues arise. Health dangers towards the vulnerable demographics, such as elderly and children, which inhales smoke from the passive smoking. There are fire hazards in industrial places where flammable sources can be ignited from cigarette smoke and butts. Next is littering when it comes to air pollution from smoking and land pollution due to cigarette butts. So before we go on ahead to the demonstration part, I'd like to show you the end result of our product, which sends real-time notification alerts on smoking offenses through these interfaces. The first being WhatsApp. As you can see here, we can view information such as the place, location, date, and the frame taken of which the offense occurred. So the second interface in which we send our data to is through a web application where owners or authorities can easily manage and see recent offenses being made.
So for this project we are using a Raspberry Pi, which is connected to a Neural Compute Stick 2, which is developed by Intel, and this Raspberry Pi is also connected to a monitor which is displaying our console, which will be used to run the Python script. So once the Python script is run, the AI model, which is the Tiny Yellow V3 object detection model, will run on a test video, and it will try to detect two classes, smoker and cigarettes. So after it detects something, it will send the frame to a web app, and then it will be displayed to this screen on the left, and on the same screen on the right it shows a WhatsApp message. Once there's a detection, the frame will be sent via WhatsApp to this chat. So let's start the script. So once we start the script, we'll see some info messages like loading models, preparing inputs, opening video file. And then a window pops up. So in this window, it's basically this is basically the test file, and the model is trying to detect one of two classes, which is smoker and cigarettes. So as we see, like right now we just see the cigarette box and there's no cigarette inside, so it's not having any detections on the terminal. And we'll see once once she brings out the cigarette and it is properly inside, we'll see a detection by the model on the left. As we can see, the class is detected on the left, and on the web app, if we go, we see that it sent the frame where the person is holding the cigarette to the web app, and similarly it is also sent to the WhatsApp messages where it is being shown, where it's shown. Then if we go over to the console, we can see the if frames per second, the processing speed at which the AI runs, it's 3.79 or approximately 4 FPS. So this is due to the fact that we're only using one NCS tool. Increasing the number of NCS sticks will increase the FPS as well. So that's all for the demo. Thank you very much.
Here we have an overview of the methods, frameworks, software tools, and services utilized in our product. It can be split into four main components, with the first being that our smoker detection system first takes camera frame input and performs real-time inference with a fast and efficient model called TinyYOLO v3, utilizing Intel's OpenVINO toolkit. And once illegal smoking is detected, the specific camera frame image and information, such as the time, date, and location of where that incident happened, is sent to AWS IoT Core via the MQTT protocol, which is a lightweight and fast IoT communications protocol. And once all the data is sent to the AWS IoT Core, the Lambda function is then triggered to send that data through our notification interfaces, which are through the web application and through SMS. Next, the sent data from the AWS Lambda function can then be viewed in the web application, which is built on Firebase and also through WhatsApp utilizing the Twilio API for real-time and fast alerts. After this, authorities can immediately take action towards the incident. Here we have an overview of the time allocation for building our product. So 25% of the time was spent on data collection, collecting images from online sources. 25% of the time was spent on training the model used for detecting smokers. 10% of the time was spent on optimizing that model for accurate classification. Next, 30% of the time was spent on integration with various software tools such as AWS services, Twilio, and Firebase. 10% of the time was then spent on building the dashboard. Here's an overview of the budget allocation for our product. We've structured it to be the cost per year of one device using our product. As you can see, the only service that will incur cost is Amazon Web Services, with the rest of the services such as Firebase, OpenVINO, Twilio, offering free tiers for an indefinite time. We've calculated this to be sufficient for our product, and thus the overall cost for one device using our product is about 5 ringgit per year. Now, due to the coronavirus pandemic that is currently happening, we faced some limitations when it comes to building our product. The first limitation is that we couldn't make our own dataset from real-life smoking scenarios where different angles and different lightings may have been applied to increase the overall accuracy of our model. Currently, our product utilizes online image data sources, of which some images may not accurately model real-life smoking scenarios. The second limitation is that there was some shipment issues with our Raspberry Pi camera, which forced us to use a video file input instead, reducing the overall FPS due to the decoding process of the file. These limitations are a very small hurdle and can definitely be solved after the pandemic is over. And with that, we finally reached the end of our presentation, and we hope you guys enjoyed and understood the whole workflow of our product. If you guys have any questions, please leave them below, and we'll try to get them as soon as possible. Thank you, and stay safe always.